Bismillahirrahmanirrahim. In this video, we will discuss about some features of Oracle PL like collections and records, accessible by clause, optimize function execution in SQL. So we start with qualified expressions for collections and records. Ever since Oracle Database introduced the object-related model in version 8, PL developers have been able to use constructor functions to construct nested tables, V-arrays, and object type instances. A constructor function is a function created implicitly by Oracle Database that has the same name as its type. The easiest way to understand constructor function is to look at an example. To initialize a nested table of integers with 3 elements, I can do this. You can see the example. And numbers underscore t is the name of the type, but it is also the name of a function. For a nested table or V-array type, I simply pass in a list of expressions, and the function returns a collection populated with those values. If we don't pass in any values and simply call the constructor function, the collection will be initialized but will be empty. But before Oracle Database 18c, if we want to use an associative array, in other words, an index by table, this direct functionality was not allowed. Instead, we had to assign elements to the array one at a time. As you can see, okay. We had the same challenge with populating values of fields in a record. Either we wrote our own function to create and return a record, or we wrote field by field assignments in the executable section of our block, as you can see in the example. That is cumbersome, irritating, and as of Oracle Database 18c, we don't have to bother with that sort of things anymore. Now, any PLSQL value can be provided by a qualified expression, just like a constructor provided an abstract data type value. PLSQL uses the terms qualified expressions and aggregate rather than the SQL term type constructor, but the functionality is the same. Qualified expressions improve program clarity and developer productivity by providing the ability to declare and define a complex value in a compact form where the value is needed. Here is a block of code that demonstrates qualified expressions for both records and associative arrays. So you can see the example. Type is defined and then this type is being used here. So example is simple. Control access to code with the accessible by clause. Before Oracle Database 12c, PLSQL could not prevent a session from using any and all subprograms in packages to which that session's schema had been granted execute privileges. Developers had to accept that violations of their subprograms would or could occur, or else write code to restrict access. As of the Database 12c, you can now include a clause in the header of your program unit that specifies an approved list of other PLSQL units that can access the PLSQL unit you are creating or altering. This is accessible by a clause. You add this clause to the header of your package, or starting with Oracle Database 12c release 12.2, even subprograms within the package, and provide a list of the program units that are accessible. As you can see, example, create package, accessible by, and then your package name or whatever you like. If anything besides the subprogram in your package calls mypackage.myproc, you will see this compilation error, PLS 00904, insufficient privilege to access object my_package. One use case for this feature is to improve manageability of your code base. It is quite common for packages to grow very large over time as more and more functionality is stuffed into them. Those packages can then become development checkpoints. Multiple developers need to work on different parts of the package, but only one can edit and compile at a time. Also, as the package grows in size, compile time increases. A way to resolve this to break up that big package into multiple smaller packages. Those smaller packages will often contain what were previously private subprograms which were not listed in the package specification. Now those smaller packages do become available through the specification, but they were never intended for general public access. That is a recipe for disaster. You can then use the accessible by clause to restrict how these reorganized subprograms can be accessed. Optimize function execution in SQL Pragma. It's already wonderful that you can call your own user-defined functions in SQL. It's not quite as wonderful that each time you do so, Oracle Database executes a context switch from the SQL engine to PLSQL engine, automatically performing a variety of steps such as data type conversions when necessary. The downside is that context switching's overhead can have a substantial performance impact, which is why PLSQL has bulk processing feature such as for all and bulk collect. You can reduce the cost of a context switch to make a function call in SQL in two ways: the UDF Pragma, the with function clause. The UDF Pragma is a compiler directive that says the following in effect: I only or almost always call this function from within SQL. Therefore, do at compile time some of the steps you would usually do for the context switch at runtime. There is literally nothing for you to do except add the Pragma. For example, create or replace function. My function return date is Pragma UDF. Simply, the PLSQL compiler will take it from there The performance impact will vary according to the types of parameter you have in your function. Note that there is still a context switch, but the runtime overhead cost is reduced. You can also define your function inside a select statement using the with clause. You can even define procedures inside the select, but those procedures can only be called by a PL/SQL function defined in the same way. So you can see the example here in with clause example. As with UDF, there is still a context switch, but the runtime cost is reduced. The with clause can be most helpful when a formula appears multiple times in the same SQL statement and you would like to avoid the repetition. It's also useful when you are running queries in a read-only database and you simply cannot create functions or any other PL/SQL program units within that database. So hope you understand the usage and benefit of UDF Pragma and the with clause functionality. So in this video we will discuss this, and we discussed that. I hope you understand, and you definitely you will test that, but it is available only 12.2c. Hope we will meet soon with some new discussion, with some new knowledge. Thank you for listening. Till then, bye bye.